In this video, I'd like to talk about angle of elevation and angle of depression. And so these are easy to work with, and they're commonly used in some trig application problems. You just have to make sure you draw your diagram correctly and draw these angles in the appropriate place. So when setting up your diagram or drawing an angle of elevation or angle of depression, what you got to remember is that wherever you're drawing it from, like say this point here, you draw them from a line that is horizontal. Think of it like being parallel to the ground. And your angle of elevation is how far you would elevate from that horizontal line parallel to the ground. The angle of depression is how far you would depress from that horizontal line that's parallel to the ground. So as long as you draw those up correctly, you should make quick work of the problems. So for example, let's say there's something you want to determine the height of. There's a tall building here and you want to know how tall it is. And so let's say you walk 500 feet away from the building. Again, we want to know the height. And from this point we're standing at here, we measure an angle of elevation. So from this horizontal line, how much we elevate to see the top of the building would be our angle of elevation. And let's just say that that was measured at 40 degrees. Okay. Well, we can assume that the building or the tree or whatever it is you're trying to find the height of is roughly perpendicular to the ground, straight up and down. So we have a right triangle. So we could just use good old SOHCAHTOA here. We just need to set up a trig function that captures that height there. So if I wanted to, looking at 40, I've got the side opposite and the side adjacent to it. So that's opposite and adjacent is TOA, that's tangent. I could say tangent of 40 degrees is opposite over adjacent. And if I multiply the 500 to the other side, let's throw that in the calculator. Oops. Looks like the building is about 419 and a half feet. So let's just say approximately 420 feet. Okay. So that would be angle of elevation. Again, it's from this horizontal line, how much we elevated to get to the point where I can see the top of the building. Let's think about an angle of depression problem. Let's say that there's some, I can't draw, but let's say there's some bridge you're standing on and you want to determine the height of that bridge. So let's say you have your friend walk out a certain distance from under the bridge. Let's say they go out 100 feet. And from where you're standing up here, you measure an angle of depression down to where your buddy is standing. So you would look straight out, right? Parallel to the ground where your buddy walked, and you would depress down some angle from there. All right, so let's say that angle of depression, and I'm going to erase the bridge because that's almost, I think, confusing the picture. But let's say the angle of depression that we had to look down was 20 degrees. Okay, well, I need to know what some of these angles inside the triangle are. And depending on how comfortable you feel with some geometry, this angle and this angle are actually alternate interior angles. We can add to the picture and show that. So they would be the same. Or you can also think of it that up here, we make a 90-degree angle, right? Because that yellow line is supposed to be parallel to the ground. Not quite so in my picture. So if that little angle there is 20, that means this guy up here has got to be 70. So I can work with that angle. There's many ways to do a trig problem or any math problem, but I'm just going to stand at that angle. And again, I'm looking at opposite and adjacent. And so I could set that up with another tangent function. I could say tangent of 70 degrees would be the side opposite the angle, which is 100 feet, over the side adjacent the angle, which is h. So to clean this up, I could multiply the h to the other side. And then to get the h by itself, I could divide both sides by tangent of 70. And we'd get 100 over tangent of 70 degrees. Which means the bridge is roughly 36.4 feet tall. Okay, so again, working with angle of elevation or angle of depression, from wherever you're standing, you would imagine a horizontal line, and it's from that line that you measure how much you elevate from there, if it's an angle of elevation, or how much you depress, go down from there, if it's an angle of depression. Okay, keep up the good work.